Here's your basic one. I'll put them right here in case you can't see them. So the 30, 60, 90, what would be opposite my 90? 6. And? 3 radical 3. Alicia, question?
No.
You see where we are? You have to set your first 2 up. Set your first 2 on that orange page. Set your first 2 up like this. 30, 60, 90 make opposite the 30 is a 1. Opposite the 90 is a 2. Opposite the 60 is a radical 3. So then we just did a concept of similar triangles. And the 45, 45, your equal legs are 1 each, 1 and 1, and your hypotenuse is a radical 2. Jeremiah?
Would be 1 squared and 1 squared?
How did you go from radical 2 to 2? You squared it. Okay, you squared this. But if this is a 1, do I want to square 1? What did you actually multiply radical 2 by? You multiply it by itself, which was what? Radical 2. So why don't you multiply 1 by radical 2? So now we kind of made this have a different look. You took your hypotenuse, which used to have the radical, and now your sides have the radical instead. And how can we check this to make sure that this works? Yeah, it looks a little weird. So what are you calculating, Jeremiah? What are you calculating?
Thinking back to trade.
Okay, so tell me what you're thinking.
We use the cosine and the sine.
Okay, think a little simpler.
Sine A over sine.
A little simpler. 3 sides of a triangle. A squared plus B squared equals C squared. What's this guy called? Pythagorean theorem. So if I took these, just to make sure this works, before we do anything else, let's make sure we're right. So this becomes, what's radical 2 squared? 2 plus 2 is 4. Good to go? Good to go. Now, the last one we're going to do is we're going to get ourselves set up for a unit circle. And does anybody remember what the radius is on a unit circle? Unit? What does unit mean? 1. So we're going to make our hypotenuse be 1. Okay, our hypotenuse is going to be 1. See if you could find me the corresponding sides. This is a special triangle that we're going to use for your unit circle. And if your radius is 1, we want our hypotenuse to correspond to a 1. So see if you can use your concept of making a ratio and find me your corresponding sides. Here's the one you know and love. Remember, everything has to be exact value, so try not to use your calculator. Need exact value. So if I'm going from 2 to 1, how am I going to get there? Divide by 2. So if I divide this by 2, what do I have to do to this side? And this side? Okay, so opposite the 30 is 1/2, and opposite the 60 is radical 3 over 2. Agree? They look weird, but we just made a similar triangle. So we took this guy, and we went from a radical 2 to 1. Same concept of dividing. What am I going to divide by? To make this hypotenuse be a 1. Radical 2? So would radical 2 over radical 2 be 1? So then I got to divide this guy by a radical 2 and this guy by a radical 2. So think back to your algebra 2 for a second. Algebra 2, remember when you did the sine and the cosine for a 45-degree angle? They're both the same. And that's because what? Sine 45 and cosine 45 are both the same. Because they're both the same what? They have the same angle for both of these, right? Both of these are exactly the same, so their sine and their cosine are going to be exactly the same. Good. Now, back in algebra 2, you probably remember doing this. Multiplying both top numerator and denominator by radical 2, and you came out with radical 2 over 2. Well, the good part is, in pre-calc, we don't have to rationalize your denominators anymore. So we can leave it as 1 over radical 2. It works really nice when we go to take reciprocals, because then all you have to do is flip this guy over. You don't have to unrationalize anything. You can just flip them over. So you don't have to worry about rationalizing. But you do need to make sure I get these exact values. Okay, I've got to have those exact values. Okay, now, before we put this on our unit circle, let's take a look at your unit circle for a second. We agreed that your unit circle has a radius of 1, right? All right, we agreed that your unit circle has a radius of 1. My board never cooperates. Okay. When you incorporate your unit circle onto a coordinate grid, your xy axis, you're able to use your characteristics of your xy axis to help you rotate your angles around this unit circle. All angles start from here, your positive x-axis, and they open up counterclockwise. So our angles start here at the 0, whether we're 0 in degrees or 0 in radians, and they move around this unit circle. And they can keep going around this unit circle. Okay? Our radius is 1, like we said before. Now, do you remember back in 8th grade how you labeled your quadrants? Where was 1? And the positive x and the positive y. Where is 2? To the left. Yep, negative x, positive y. Good. You already have your grid with your circle working. Good. Now, do you see why we did that? Look where your angles come from. They start here. So in quadrant 1, I'm 0 to 90. In quadrant 2, I'm 90 to 180. In quadrant 3, I'm 180 to 270. And quadrant 4, I'm 270 to 360. This is why we actually label them in that order, because your angles start in standard position and open counterclockwise. Where would a negative angle open? Quadrant 4. Good, it's going to just open the opposite way. Now, I know way back when you were doing trig, you got used to the mnemonic SOHCAHTOA. I want you to get used to using your y's, your x's, and your r's instead of SOHCAHTOA. So if we're looking at your unit circle, and we go to a 30-degree angle, and we drop your triangle in here, and we're going to put this on your unit circle in a second. Instead of saying opposite, adjacent, hypotenuse, opposite is the same as the y. Adjacent is the same as the x. And hypotenuse is my radius. We're just going to call these by x, y, and r, because once we use your characteristics of your grid on this, it's going to make it make a lot more sense. Now, here's a cute little trick that I learned a while ago. You love your SOHCAHTOA. So, we could take your SOHCAHTOA and convert it to X, Y, and R. So we're going to take sine, cosine, tangent. On your unit circle, on any circle, our hypotenuse is our radius, right? So your H's become R's. Your opposite is your Y value. So all your O's become Y's. And your adjacent is your X value. So your A becomes X. And another way to remember this is XY in alphabetical order, AO in alphabetical order. So my sine is Y over R. My cosine, X over R. My tangent, Y over X. I want you to start thinking X, Y, and R instead of opposite, adjacent, hypotenuse. Okay? And your reciprocals, even though we take this and we take it 1 over this, your rules of fractions, keep, change, flip. You're going to keep this, change, and flip this over. It just takes this and flips it over. So it's easier to remember that way. And like I said, the nice part about not rationalizing, you don't have to worry about where was this rationalized from. Okay, this will start making sense as we start moving around your unit circle. So now we're going to go to these guys. And we're going to apply your special triangles to this. Okay. I want you to extend this a little bit and make this like an axis. This is your y-axis, this is your x-axis. So the first one we're going to do is your special right triangle of 30. There are 4 angles that I can use my special right triangle for to give me exact values. We're going to find them. Remember when we say exact values, don't pick up your calculators. We're going to do these with your radicals in them. There are 4 for each one. Why? Because we have 4 quadrants, right? So we're going to start with your basic triangle, and because this is a unit circle, we're going to use the last one that we did on that page. So our radius has to be 1. So the one that had the radius of 1, what was the side opposite the 30? 1 half. Good. What was the side opposite the 60?
Radical 3 halves.
Good. Radical 3 over 2. Good. Now, I like to call this my information box. This is all you need to find all your other pieces. Once you establish where your triangle is, you can do your sine, your cosine, your tangent. You can do all your reciprocals right from here. Because we know sine is y over r. We have a unique situation here because our unit circle, what is the radius? 1. So all we need to know is that sine is equal to y. So what is my y value? 1 half. So the sine of 30 is 1 half. So the cosine of 30 is x over r. And again, my r is 1, so it's just the x value. So what's my cosine? Good. Radical 3 halves. And my tangent of 30, we have to mess around with this guy a little bit, is y over x. So we take your y, you place it over your x. And if you do keep, change, flip, what's the shortcut to keep, change, flip because your denominators are the same? Just cancel them out. Because keep, change, flip is going to flip this over and put my 2 up here, and we can cancel it out. And there's the beauty of our pre-calc. We don't have to rationalize. So we found all your exact values for 30. Okay? So you see that chart at the back of that packet? The table on that? Fill in those pieces for 30. Find your chart. You don't have to memorize this. You just have to know how to set this up to find it. So come to your 30 degrees. Fill in your sine, cosine, tangent. And let's see if we can fill in your reciprocals at the same time. So what's the reciprocal of sine? Cosecant. Good. Here's a little trick for reciprocals. What's the reciprocal for tangent? Everybody gets that one, right? Now, notice, they start with different letters. So the reciprocal for sine can either be sine, secant, or cosecant, but it can't start with the same letter. So it's got to be cosecant. The reciprocal for cosine's got to start with a different letter, secant. So on your chart, fill out those parts. Let me see if I can just... I know. So fill in these parts. We'll get your radians in a minute. Sine, we said was 1/2. Cosine, radical 3 over 2. Tangent, 1 over radical 3. Sine and cosecant are reciprocals. So what will my value be for this?
2 over 1.
2 over 1 or 2. How about my secant?
2 over radical.
Good. 2 over radical 3. How about my cotangent?
Radical 3 over 1.
Or just radical 3. So the beauty about not rationalizing this, it makes it so much easier to take the reciprocals. Okay? Now, let's see if we can find any more angles that deal with 30. Okay. So remember, your angles start here and they rotate this way. So if I want to make an angle in quadrant 2, how can I get that triangle? Think back. Think back to something that we know how to do. How can I get that triangle to be in quadrant 2? How? My angle we're going to subtract, right? But how can I get that triangle? With the transformation, great. What transformation can I use?
Reflection.
A reflection. The horizontal shift will put me over here the same way. So a reflection will give this to me as the same triangle, right? So this is my 30. This is my 60. And when Azure said we subtract, if this is 180, and we subtract 30 from 180, what angle is that? 150. Okay, so now, because it's the same triangle, shouldn't it have the same cosine, sine, and tangent? So all I have to do is say, okay, sine of 150 is 1/2. Cosine of 150 is radical 3 over 2. Tangent of 150 is 1 over radical 3. Is that right? No. What's missing? A negative. Where's the negative coming from? I've got the same exact triangle in the second quadrant. Where's my negative affected? Well, according to your grid, what changed from quadrant 1? Your x value or your y value? Your x value. Look, your grid has a negative here now. Here's my information box. I am now negative radical 3 over 2. My y stays the same. And what about my r? Should I make my r negative? No? Why not? Why doesn't a radius ever become a negative? Okay, it's a radius because I'm going one either way. So you're basically measuring what from the center to the end? The distance. Good. So the distance can never be negative. So remember that. Your radius can never be negative. So once you make this information box and you do sine y over r, well, your sine was positive. That's good. We got positive. Your cosine was x over r. Oh, well, your x is negative. There's your negative. And your tangent is y over x. Well, your x is negative. There's my negative. So even though we have congruent triangles, what's happening is your axis is saying, okay, x is now negative, y is now positive. All that's going to change is anything that dealt with an x. Back in Algebra 2, you probably remember the all students take chemistry, or all students take calculus, whatever they taught you, or whatever Mr. Baker taught you, or whatever Mr. Schaefer, he always has unique ones for that. Whatever they taught you for those, that follows this. But if you incorporate your xy axis into your circle, you have all your parts. So let's follow the same pattern again. Keep this pattern going. Let's reflect it in your x-axis. So now watch what's going to happen. My x is negative. What else is negative now? My y is negative. And my r, remember, is never negative. So looking at this, let's see what angle we get. In degrees, what angle is this? If I went 30 degrees past 180, what angle am I? 210? Okay? So I'm angle 210. So what's the sine of 210? God bless. What's the sine of 210? Sine is what? X or Y? Y. Oh, there it is right there, staring at me. Negative 1/2. What's the cosine of 210? Yeah? Now here's a tricky one. What's the tangent of 210? 1 over radical 3, and it's positive because why? 2 negatives. Negative divided by a negative. That number itself, 1 over radical 3, will still be there. But you have 2 negatives now. So 2 negatives give me a positive. We could do this one more time into quadrant 4. What angle will we get? 330, right? 330? We're 30 degrees short of 360. So now, make your information box. Do this constantly, guys. This is what's going to help you. What is y in quadrant 4? Positive or negative? Negative? So again, I know my values is radical 3 over 2 is 1/2 and 1 over radical 3, but depending on which one I make negative. So which of your 3 functions will become negative? Y. So who deals with the y? Sine. Good. So the sine is negative. And what else is going to become negative because of that? Tangent. Good. And so my tangent will also become negative. And my cosine will stay positive. Okay? Now, there's another little trick to remember. As I go across my unit circle, I know I'm 1 away. This is 1, 0. I know this is 0, 1. Somewhere in between here is a point on my circle. And what are the coordinates? How do I label coordinates? Using which variables? X and Y. This guy has an XY. So what is the value of X for this first quadrant? What's the value of this guy? Radical 3 over 2. What's the value of Y? 1/2. So there's my point. Okay. I can follow these points all the way around because aren't I on a coordinate grid as well? So, and that'll help you figure out where's the negative, where's the positive. Okay, we're going to do one other thing with this. We're going to get you to think radians. Okay? Now, does anybody remember the formula that they use for radians to convert from degrees to radians? Okay, so if I have a 30-degree angle and I want to get it to radians, 180 over pi, I want the pi where? On top. So just flip that over. So pi over 180. So what do you do over here? No, there's no equal sign. Reduce. 30 goes into 180 how many times? 6. So watch. All I need you to do is find me the first angle. Pi over 6. Okay? Now, on your graph, this is 0. This is 180. 180 is equal to pi, right? This is 360. What is 360 in terms of pi? 2 pi. Okay, so watch. We've got a little pattern going on here. If I know my denominator is 6, I'm going to go to my pi, and I'm going to say, I want something over 6. So I want to convert this guy. It's over 1. I want to make it a denominator of 6. I want the denominator to be the same thing. So what's my numerator? I want it to cancel out the pi. So I want to make a fraction. What's my numerator going to be? I need to multiply this by 6. I need to multiply this by 6. So what's it going to be? 6 pi over 6. Doesn't that cancel out the pi? So I take shortcuts. I take whatever my denominator is, and I put it on the denominator and the numerator. Okay, stay with me. 2 pi. 2 pi means I doubled pi, right? So if I double 6 pi over 6, what do I get? 12 pi over just the numerator, 6. So there's your pattern. Watch. You got this nice little bow tie going on. It goes 1 up, 1 down. So I've used my axes as my guideline. My first one is my pi over 6. As I rotate around here, whoops, I stop 1 short of 6 pi over 6. What comes before 6 pi over 6? 5 pi over 6. There's my angle. I'm 1 past 6 pi over 6. What am I? Good. 7 pi over 6. I keep coming around counterclockwise. I'm 1 short of 12 pi over 6. 11 pi over 6. There's my angle. Find the pattern. We're going to take our base angle and see what is it. We're going to make the pi be the same number, top and bottom, so it cancels out the pi. We're going to make 2 pi be doubled. Your triangles are going to go 1 up, 1 down. If they went up 2, we're going to end up with a 60-degree angle. So this is going to work. We'll do this again. Good? So far? Questions? All right, let's see if we can apply this to your 45-degree angle. It's a lot, you're right. It's a lot. Some of it will come back to you, and some of it might not come back as easily. Could we? Oh, you actually want to go back to logs? Well, don't forget, in the beginning, when we start this, a lot of this is review, so we're all coming in at different ways. So it's kind of like I got to get everybody on the same page here. And I got to erase this thing over here, so I can't erase it. All right. I'm just going to X out of this. And bring it back up. All right, so let's hit your 45 one. I'll give you a breather while I'm getting my thing working again here. All right. So, back to your unit circle, 45. Go back to the last triangle that we worked on for your 45. Give me your unit circle. So I want to convert this to, I want to take your last one for when your hypotenuse is 1. Go back to your orange page. 1 over radical 2. Good. All right? So we're going to do the same thing. We're going to remember that we're on an xy axis. And we're going to let the positive and negative of your xy axis actually drive that who's positive, who's negative about your trig functions. So we're going to start with your 45-degree angle. Our radius is going to stay 1. The 45 is nice because we said before, both of these angles are the same. So your sine and your cosine are going to be the same. Your values of them. The positives and negatives are going to be driven by where you go, where quadrant you go in. So again, start with your basic information box. On your unit circle, remember, on your unit circle, if the sine is y over r, on your unit circle, r is 1. Tomorrow will work when r is not 1. But we'll see that they all come down to the same basic ratios. So therefore, what's the sine of 45? Go ahead. 1 over radical 2. What's the cosine of 45? What's the x value? X over r. 1 over. They probably look a little different because last year in algebra 2 you always rationalized. You went radical 2 over 2. When I first started teaching pre-calc after teaching algebra 2, I kept always rationalizing those. How about the tangent? The tangent of 45 says y over x. So, good. Very good. So since they're both the same, 1. So again, Hetzel said maybe we should do a reflection. We'll reflect this here. And it'll be the same properties again. This time x is what? Positive or negative? Negative. Y is positive. And remember your radius always stays positive. So of the 3 functions, which one becomes negative? Anything that deals with an x, which is what? Cosine, and what else? Tangent. Who deals with the sine deals with which one? Y. Good. So we should get all those for this guy. We're going to do the same thing here. And again, information box. Now we notice the y is also negative. So that y being negative makes our sine negative. What happens to our tangent? It becomes positive. Good. So what's the cotangent? What's the cotangent of this angle down here? Same thing. Absolutely. Same thing as your tangent because it's 1 over 1, right? Absolutely. Good job. And when we come here, another reflection, just set up your information box. So which one has an effect in quadrant 4? Which one? The y, which affects which function? Which ratio? Sine. Good. And eventually will also affect tangent. So are we okay with that? Good. Now let's see if we can name these with radians. Let's work our radians. So I'm going to start with 45. And I'm going to convert a 45-degree angle. Automatically, what am I saying to myself? Divided by, good. How many times does 45 go into 180? 4. So this guy is pi over 4. So remember, this is pi, and this is 2 pi. In terms of fourths, what do I have to put on top now, which goes in my numerator? I want it to cancel out the pi. I can't change the value. But I did change the denominator. If I change my denominator and multiply it by 4, what do I have to do to my numerator? Times 4. So 4 pi over 4, doesn't that cancel out the pi? So when I double it, what will my fraction be? 8 pi over 4. Good. So we know our first quadrant angle. What's our second quadrant angle when I'm 1 before I hit the 4 pi over 4?
3 pi over 4.
Good. 3 pi over 4. I'm 1 after.
5 pi.
Good. 5 pi over 4. And now I'm coming all the way around again. I stop short of 8 pi. What am I?
7 pi.
7 pi over 4. Good. Good job. Good. Now you can fill in your 45-degree angle in your chart as well. It's nice because your cosine and your sine are exactly the same. And what happens to the reciprocal? What's the reciprocal for sine?
Cosine.
Cosecant. So what would that be if I flip this over?
Radical 2 over 1 or radical 2.
A radical 2. Good. And we just discussed the cotangent stays exactly the same, 1 over 1. Good? We have time for one more. Let's finish up this 61. Are you seeing a pattern? So it's not so scary, right? All right. So we take this again. Let's expand this. Let's drop our 60-degree triangle. It works very, very similar to your 30. So we take this guy, opposite the 60 is what side? When we use your unit circle. Radical 3 over 2. Good. What's opposite your 30? 1/2. Good. So again, all right, so tell me, what's this XY point right here? 1/2. Okay, now, an easy way to do this, since we're on the unit circle, let's just fool around a little bit here. If this is X and Y, and we said before, if the sine says I'm on my unit circle, then it's just equal to the Y value, I'm going to make this say my X is my cosine, my Y is my sine. I'm on a unit circle. Makes perfect sense, right? So now, what's my sine of 60 degrees? Radical 3 over 2. Good. What's my cosine of 60 degrees? 1/2. Very good. And my tangent of 60 degrees, that one we have to mess around a little bit. We're y over x. So we're radical 3 over 2 over 1 over 2. Radical 3 over 1. Good. Now think back for a second. Oh, I thought you were asking me a question. Think back for a second. What was our tangent of 30 degrees? Of 30. 1 over radical 3, right? Okay, so watch. Let's put this on your graph. Let's put this on your chart. This way we can complete your chart. Let's look at something here for a second. This will make things a little clearer too. Okay, sine was 1/2. Cosine radical 3 over 2. Tangent 1 over radical 3. 60 said radical 3 over 2. 1/2. Radical 3. What do you notice about this?
They're opposite of each other.
They're opposite of each other. Do you remember what this is called when you have two angles in a triangle? You have to add up to 90. Do you remember what they're They're complementary angles, but in trig, do you remember what we call them? Co-functions. These are co-functions of each other. Okay? These are co-functions of each other. That's why you see this swap out here. All right? And again, for that 60-degree triangle, we can flip it all around into all 4 quadrants. And you should be able to flip that around tonight. So tonight, what I want you to do is finish filling in your 60. Finish your 60-degree triangle. And then the homework is all based on the angles we did today. Take your information box. X equals Y equals R equals and just time whatever it is it's asking for. So that'll give you a chance to digest everything. Remember, if you need it, it's on Edmodo.